Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into who owns the riser, governing shared infrastructure in multi-tenant buildings, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production. Joining me today is Michael Harrington, and together we'll break this down from a practical, real-world perspective.
Cold open. Imagine a busy weekday morning. A contractor on a fit-out team pulls a riser panel in a telecom closet, and 2 floors of tenants lose phone service, building automation trips, and a point-of-sale system goes dark. No one knows who owns that riser, whose change order covered the work, or which vendor has the keys to the closet. Within minutes, tenants are calling leasing. Leasing calls facilities. Facilities calls IT. And nothing is fixed because responsibility is fuzzy. Who's responsible when shared infrastructure breaks?
That scenario plays out more often than people think. From an operational standpoint, the immediate question I ask is, what breaks if this goes down? Once you spell out the downstream impact, the governance question becomes urgent and solvable.
Over the next 10 minutes, we'll walk through why ownership gets fuzzy, the trade-offs between a landlord-led standard and tenant autonomy, and a practical checklist you can use to map responsibility before somebody pulls a panel. We'll include anonymized examples Michael's seen in the field, and end with 3 immediate actions your team can take. Let's start with root causes. Michael, help us set the scene. Why does ownership of shared stacks, risers, closets, feeds, become ambiguous in the first place?
There are a handful of repeatable patterns. First, contract silos. Lease agreements, construction scopes, and service contracts are often written by different teams that never reconcile a single source of truth for shared assets. Second, short-term incentives. During a fit-out, it's cheaper and faster to push responsibility onto the other party. That's tenant scope, or that's landlord scope, and nobody revisits the decision when the building changes hands. Third, documentation decay. Drawings, change orders, and access lists live in different places, and once a vendor leaves the site, operational knowledge evaporates. Those 3 together create a perfect storm for ambiguity.
So the immediate decisions that speed a fit-out along can become long-term outages waiting to happen. Can you give an example, anonymized, where that decay produced a real problem?
Sure. I worked on a property where a tenant installed a private fiber path from the basement riser up to their floor. The path crossed multiple landlord spaces, but the installation was documented only in the tenant's handover binder. 2 years later, a different contractor working for the landlord re-terminated a fiber in the same riser during a lighting upgrade and severed the tenant's path. The tenant lost their internet for hours. The cost to resolve included emergency technician time, new patchwork to reroute services, and a tenant retention negotiation. That's fine until it fails. Then everyone feels it immediately.
Let's zoom out and look at governance trade-offs. When does a landlord centrally control risers and closets? And when does it make sense to give tenants autonomy over their runs?
There's no one-size-fits-all answer. Centralized control works when scale, uptime, and standardized maintenance are priorities. Think multi-tenant office towers with shared fiber, centralized security, and uniform tenant expectations. Centralization simplifies maintenance boundaries and capital planning. The trade-off is flexibility. Tenants with specific needs, co-location, specialized automation, or unique network topologies need autonomy to innovate. It's about identifying interfaces where failures are most costly and locking those down, while allowing flexibility where failures are tolerable or easily remediated.
How do you handle transitional ownership, say during a fit-out or a handoff from contractor to operations?
You need explicit, time-boxed handoffs in the project plan. A simple example. Define a control point at the riser boundary with a named responsible party and a 30-day acceptance window. During that window, the installing contractor remains on call to validate connections and documentation. After the window lapses, ownership moves to the operations team. That preserves accountability and reduces the chance the asset sits in limbo.
Let's move to concrete impacts. Michael, walk us through 2 anonymized incidents that illustrate what goes wrong when governance fails. and the operational signals that indicate risk is increasing before an outage happens.
Incident 1. A security camera feed went dark during a weekend. Investigation found a contractor had temporarily repurposed a riser circuit without updating access lists. The telltale signals beforehand were inconsistent labeling in closets, multiple vendors with independent key sets, and recurring informal workarounds logged only in email threads. Incident 2. During peak season, a tenant experienced intermittent HVAC control faults. Root cause, shared building automation controllers had split responsibilities. Tenant-side logic called vendor-side endpoints, yet no one owned end-to-end testing. The early signals were repeated service tickets that got assigned back and forth, and a lack of a single troubleshooting runbook.
Those signals, mismatched labels, split tickets, and ad hoc keying are things teams can look for now. So what's the practical framework you recommend to prevent these failures?
Start with a short checklist and a 90-minute ownership mapping workshop. The checklist has 4 pillars. 1. Asset cataloging. List risers, closets, feeders, and control points. Include physical location, patching, and vendor contacts. 2. Decision ownership matrix. For each asset, name who can make changes, who signs off on work, and who handles emergency response. 3. Maintenance boundaries. Define who maintains cabling, who owns cower feeds, and who handles labeling and access control. 4. Minimum contractual language. Require handoff documentation, test sign-offs, and a 30-day acceptance period in fit-out scopes. Those items are operational recommendations. Your legal team should review final language, of course.
Let's make those 3 immediate actions even more concrete for listeners. Prioritize interfaces, run the mapped workshop, and document 3 things right now. Michael, what 3 things should teams document this week?
Document these 3. 1. The physical path and termination points for every shared riser and closet, even if it's a 1-line note. 2. The current contact list for who has keys, credentials, and rack access. 3. Any existing exceptions or temporary workarounds that have been allowed. Put them in a single place with an expiration date. Those 3 documents reduce finger pointing and expedite remediation when something fails.
Key takeaways. 1. Unclear ownership multiplies downtime and cost. Identify the interfaces that matter most. 2. Governance is a practical trade-off. Standardize where uptime and scale demand it. Allow autonomy where it's low risk. 3. Run a 90-minute workshop and document the path, access, and exceptions this week. For a downloadable step-by-step ownership checklist and a workshop template, visit our resource page. If you want the checklist and the workshop template, visit gds.technology's resources page at gds.technology/builtwiredsecured and look for the riser ownership checklist. There's a printable version and a version you can drop into a meeting invite.
Final thought. Make responsibilities durable. People and vendors will change, contracts will expire, but a short and forced handoff and a living asset catalog keep operational risk visible and manageable. From an operational standpoint, that visibility is the difference between a quick fix and a multi-day outage.
That wraps up today's episode of Built, Wired, and Secured. We covered practical governance for shared infrastructure and gave you a clearer way to think about how these decisions play out beyond the initial install. Thanks for spending time with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world. Built to last, wired with intention, secured for the real world.